a real part and an imaginary part. Now, first of all, you probably need to understand what an imaginary part is, because we haven't looked at imaginary numbers yet. So let's talk about where they came from and how they're defined. Okay, now, when we saw the equation like this, it's pretty simple. What do we do? Move the 1 over, and then what do you do? Take a square root. So we get plus or minus the square root of 1, right? Now, our problem came in when we were solving this. What do we have to do to solve this? Subtract 1. And now when we go to take the square root, we ran into some issues. Because the square root of -1, until now, wasn't defined. Now we're going to define the square root of -1. The square root of -1 is called I, the imaginary unit. I is defined as the square root of -1. So that is our imaginary unit, I. Okay, so it's helpful. For example, if we were trying to simplify the square root of -40, that can happen in a problem, just like it happened here. How could we simplify the square root of -40? Well, we would break it down into 4 times -1 times 10. Now, what is the square root of 4? 2. And what did we just define the square root of -1 as? I. And do we know the square root of 10? No. No, so it would stay under the radical. Have any of you ever paid attention to my to the joke on the front page of my website?
Yeah.
It does. It has something to do with pi. Let me open up another one. It is. Okay, so I is telling pi to be rational, which is funny because pi is an irrational number, right? Yeah. And then pi is telling I to get real, which is funny because I is the imaginary, not real. All right. So let's look at how our numbers fall. We have the first numbers you learned when you were itty bitty were natural numbers. They're your counting numbers. So you learned to count stuff when you were like 2, probably. And then we went on to the next set of numbers, which are our whole numbers. What does the whole numbers add to the picture that natural numbers didn't have?
0.
0. And then you really started working in real numbers, but there's one in between, so I'm going to add a bigger circle and give myself some space. Then you probably started working with some real numbers. Like you talked about fractions, and you talked about decimals. But then in about middle school, you learned about integers. So integers just includes the whole numbers and their opposites. And then we have real. And real actually breaks down into 2 types of numbers. Real breaks down into rational, which can be written as a fraction, and irrational, which cannot. So a rational number would be like 6.25. Because we could write that as 25/4. Okay, so that's rational. And then irrational would be like square root of 2. Square root of 2 is 1.41, blah, 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 whole bunch of decimals. Or pi, or e, or there are quite a few numbers that can't be written as a fraction. So those are irrational numbers. Well, imaginary numbers don't fit in here at all, do they? No. So imaginary would be over here by themselves. Unique, but necessary. the ones that involve the imaginary unit I. Now, there is something that contains both of these, and that would be a complex number. Because a complex number has both parts. It has a real part and an imaginary part. So a complex number we're going to write in A plus BI form, where it has the real part first plus the imaginary part second. So a complex number contains both parts, a real part and an imaginary part. Okay, so for example, 2 plus 3i is a complex number. It has a real part and an imaginary part. Alright, I want you guys to simplify a couple of these. Let's do like the square root of negative 36. What do you think that would simplify to? How could we rewrite the square root of negative 36?
6i.
6i. Okay. What about the square root of negative 20? 2i root 5. Good. Because this is going to break down into 4 times negative 1 times 5. The square root of 4 is 2. The square root of negative 1 is represented by the imaginary unit I. And the square root of 5 we don't know, so it has to stay in the radical. Does that make sense? Yeah.
What if it was like the square root of negative 7 and you can't like pull it
Okay,
down?
let's do one of those. Square root of negative 7. We can think of this as negative 1 times 7. So all we can do here is pull out the imaginary unit. So it would be I root 7.
Okay.
Good question. Alright, what about this? How about the square root of negative 25 sixteenths? Alright. The negative is really just like negative 1 times 25 sixteenths, right? So what's the square root of negative 1? I. What's the square root of 25?
5.
5. What's the square root of 16?
4.
So that's 4/5 I. Nope, it's 5/4 I. Okay, questions about that? Alright, there's also something called a complex conjugate. And it has a the name sounds difficult, doesn't it? Complex, that sounds hard. Conjugate, big word. But it's quite simple. When we find a complex conjugate, we take our complex number, which is a plus bi, and the conjugate would just be a minus bi. So if we would, what was that first one I gave you? 2 plus 3i?
Yeah.
Yeah. So if I gave you the complex number 2 plus 3i, what would the conjugate be?
2 minus
2 minus 3i. So if I gave you negative 4 minus I, what would the conjugate be?
4 plus I.
Negative 4 plus I. So we just change the sign of the imaginary part. So let's say I gave you the complex number, negative 3i. You might think that's imaginary, but could I think of it as 0 minus 3i? And then it would fall in the complex. But if I was classifying it, I would call it imaginary. What would the conjugate be though? 3i. Just the opposite. What if I gave you just the number 5?
5.
It's still 5. Because this is like 5 plus 0i. And it's not going to change. questions? Okay, let's take our geometry workbooks. It's the green workbook. And we're out of the green workbook and the green book all week. And I'd like you to open those to page 296. And on page 296, I want you to try numbers 1 through 8 and 12 through 14. And then on page 297, I would like you to try 1 through 3 and 12 through 14. I know the desks are separated because I'm quizzing all afternoon, but if y'all would like to group up as you work on it, that's totally fine. You can talk about it as you go. So. And my name out to the side just in case it places it. Do you mind if it knows to misplace it? Was it? Maybe. That way it'll end up in my box.
But it's just so strange, I think.
I don't know.
Okay.
I think it's a whole number. Well, it's not imaginary. It's complex. But if you solve it, there's no straight up imaginary numbers. And the only imaginary number is 9.
Oh, yes. Yes, that's right. Never mind. Come down.
12 and 13. Write the square root of each number in terms of pi. What? I mean, I get it.
Would it be like
10i. Miss Lily.
Yeah.
What is it? Imaginary?
It's irrational, but it's still real. Irrational falls under the real category.
How do you fill in the blanks? Like, I get what you're supposed to write, I just don't.
You're just putting it, it's like a Venn diagram. Where does it go in the Venn diagram?
For number 12, though. Like,
Number 12.
not negative 10. So it'd be 10i, but it's like blank and blank.
She said it was imaginary.
Doesn't take care of the top though, it leaves the numerator
Okay,
at the top.
I'll just skip this.
I know, it's fine. You can get rid of it on the bottom.
What other
And
ones
then
do we
what
have?
is it, only the bottom, negative or not?
No, yeah, that one is. Sorry. Number 12.
I don't know what else
I
you
think
do.
it's the whole thing is you only have to do something.
I know, but that's the thing. Okay, so you the negative out and just, it's like the square root.
You're just putting the answer in the blank.
Okay, so
That's all you're doing.
okay, it was confusing.
You were just putting, that's, answer goes here is what that was basically saying.
Every time I try to help you, you just yell at me, so it's true.
Does that mean we do number 12? Or 12 through 14, right? No, I think it's the square root of negative 1 and the square root of 1. Or no, the square root of 1,000. Wait, no. Oh, no. 10i. Square root of 1 here. And the square root of 1,000. Oh my god, it's out of the square root of 100. And out of the negative 1.
Okay, let's take a look at these. Alright, the first one, it has a real part and a part, so it makes it a complex number. So 3 plus I would go here in the complex number part. Number 2, negative 17 is just a real number. There it goes. We'll put it in the real number circle. The square root of 7 is also a real number. Now this one's rational and this one's irrational, but they're both real. Both of those fall under the real category. Number 4, 9, imaginary. Negative 6 minus 5i. That has a real part and an imaginary part, which makes it a complex number. Negative 7/8 is a real number. 6.492 is also a real number. But this one, let's go ahead and simplify it, even though they didn't. The opposite of the square root of negative 25. So that is the opposite of 5i, negative 5i. So that is going to fall under the imaginary. Any questions on that? Alright, let's take a look at these conjugates then. So for this one, they were asked to find a complex conjugate, so it would be 7 plus 2i.
It says 12 through 14.
On that page?
Yeah.
Yeah, that's why we confused it.
Oh, that's why y'all were confused. Yep, it was supposed to be 17 through 22.
Oh.
Yeah. Sorry. Oops. Yeah, I hadn't showed you how to do that yet. If you did those and you got 4i and negative 4i, woohoo. No, this is 4 and negative 4. And this is 4i and negative 4i. So if you did them, got those things, that's exciting. You're ahead of the game. We're going to do that later on. Alright, so what I meant to tell you to do, which I didn't, but what I meant to tell you to do was 17 through 22. So just tell me out loud. Alright, so if we're just changing the imaginary part, does 18 have an imaginary part? Nope, so it's just 9. What about this one? Negative 6i. What about this one? 8i. What about this one?
Negative 1 plus 9.
Great. And finally, 12 minus 5i. Alright, now I understand why y'all were confused. I confused you, that's why. Alright, 32. How would we break 32 down so that we can simplify this radical? 16 times 2 times negative 1. So the square root of 16 is 4. The square root of negative 1 is I. Radical 2. Now, guys, I have seen the radical 2 at the end in a textbook. I don't like to write it this way because you have to be very careful. You don't want that radical to look, the I to look like it's under the radical. So when I write it, I always put the I in between, but these would be equivalent. So if you see an answer like this, it's not wrong, but this is the way I would write it. Okay? This becomes 2 times the square root of 9 times 2 times negative 1. So this 9, when it comes out, will bring a 3. So we get 6I root 2. Make sense? And this one we can think of as negative 1 times 1, 9. Well, the square root of negative 1 is I. The square root of 1 is 1, and the square root of 9 is 3. So it's 1/3 I. And if you want to write that as I over 3, that's also okay.
Oh, wow.
Are we good?
Can you go
Couldn't be better.
3 again? Just
Sure. Okay, so the negative 1/9 I rewrote as negative 1 times 1/9. So the square root of negative 1 is where the I came from. But then when I have a fraction, the square root of 1/9 is the same as the square root of 1 over the square root of 9. Those are equivalent. Well, the square root of 1 is 1, and the square root of 9 is 3. Alright, now these we were just asked to find the complex conjugate. Hope they didn't trick you. Because they put the imaginary part first. When we write our complex numbers, we're always going to write them in A plus BI form. So every time you write an answer, the real number will come first and the imaginary second. So this really should be written negative 3 plus I. So the conjugate would be negative 3 minus I. Make sure you're putting the real number part first, the imaginary part second. So this one's the same thing. It should be written this way. So we write negative 4 minus 3I. And this would just be negative 11I. Any questions? Okay, we're going to only perform 2 operations with our complex numbers today. We're going to just do addition and subtraction. And addition and subtraction of complex numbers are pretty simple. And I think even if you hadn't known what you were doing, you could have done this without me teaching a thing. So if I went back to that 2 plus 3I, and we added 4 minus 5I to it, what do you think you do?
Just combine the like terms.
Yeah, we're going to add real parts with real parts and imaginary with imaginary. So that would give us,
6 minus 2I.
it sure would. Not hard, huh?
No.
That's it. And then if we were to subtract, let's say we had, let's pick a different number, 6I minus 2 plus 3I. So subtraction, what would we do with the negative? Distribute it through. So we would think of this as 6I plus negative 2 minus 3I. So we're going to think of it as distributing the negative through and then combining like terms. Well, there's only one real number part, so that's it for the real number parts. And then we would combine our imaginary parts, and that would give us plus 3I. So when you add or subtract, you're just combining the real part with the real part, the imaginary with the imaginary. With subtraction, just make sure you distribute the negative, and you treat it just like an addition problem. Yes, sir?
So you basically use it as if I were just like an X or a variable, except it's actually
Correct. Correct. You're thinking of it, it looks like it's a variable. And that's why I said I think you could have done this if I haven't even told you what it was. Like if I had put that up as a warm-up problem and y'all came in here, I think you would have simplified correctly. Because you could have looked at the I and go, ooh, I is the variable. I'll add my numbers with my numbers, my variables with my variables. But in this case, I is representing the imaginary unit. So the first number is our real number part, and the second number is our imaginary number part. And so when we add or subtract them, we're creating complex numbers. But you're right, just like combining like terms when we have constants and variables with or without coefficients. Okay, so let's try a couple. Let's see if I can write the correct problems on the board now. Flip to page 304 in your workbook. I want you to try 1 through 4 on that page, and then page 305, 9 through 11. Let me verify that I've given you the right assignment.
Great. This is great.
guys are ones to look ahead and try to see what are we going to learn next. There's some topics in this section that we are not going to cover. One of them is on graphing complex numbers. Do y'all see the grid there? Graphing a complex number is not difficult. The real number part goes in your horizontal axis and the imaginary part goes on your vertical axis. So if I had this one, I would go left 13 and up 2 and put a point. And that would represent the complex number negative 13 plus 2i. So it's not really a big deal. The other thing we're not going to do is we're not going to do the absolute value. Do you see the absolute value of the complex numbers? Using the distance formula, we're not going to do that either. Right now, all we're doing is simplifying radicals, where we might have an imaginary answer. We are doing conjugates, and we're adding and subtracting complex numbers. Now, tomorrow, we're going to have more fun with these. We're going to do powers of I. So we're going to do I squared, I cubed, I bit, I 6. I might even ask you what I to the 871st is without a calculator. Yep, we can do it. We're also going to do multiplication of complex numbers and division of complex numbers tomorrow. So that's what we're looking forward to. Now you have the rest of class on your homework assignment, which truly means you shouldn't have any homework because it's not hard. This is a nice